solid, like this notebook here, has a fixed shape and volume. Has like sides and surfaces, really. They can be hard. This is pretty hard. It can also be soft, like the paper. It's rigid and flexible. So, solids have surfaces, many of them. A liquid, like in this bottle of water, you can see it's moving around, has a varying shape that conforms to the shape of whatever container it's in. So like here it'll be this, here on the floor it'll spread out, but it'll still be the same amount. You could put it in a cup and it would still be 16.9 fluid ounces. Regardless, it has the same volume, but it'll change shape. And it has an upper surface. You can see right here. On like a graduated cylinder or something like that, it would be the meniscus. But I'm not sure if this is a meniscus. I think it's just a surface. But it has one surface, the upper surface, whatever, from whatever side it's at. And then a gas is kind of like what is set off whenever I light this match. You see the smoke? That's all gas. You normally can't see it, like it's just in the air or whatever. So it's spread out. It doesn't have like a specific volume, it fills all spaces. So therefore it doesn't really have a surface. Like just now it just disappeared off into the air because it's a gas. It just fills the room or whatever area, the whole earth basically. So no shape, no volume. But solids have shape and volume, and then liquids only have a fixed volume. Remember that. So here are the physical states of matter at like a molecular level. A solid is super tightly packed and like organized. That's why it's solid when you touch it. A liquid, the particles are close together, but they're not very organized. They're pretty disorganized. That's why it's able to like move and mold to whatever shape. And then gas, the particles are far apart and very disorganized. That's kind of why you can't really see them in the air or things like that. So a change of state is a physical change. Physical form changes are like this bottle of water. I could put it in the freezer and it'll expand, but that doesn't mean that it chemically changed. It just physically changed. So it became ice. And I can switch it back to water and it is still H2O. Either way, ice or water, H2O, chemically the makeup is the same. So the physical form changes, but the composition does not. Changes in the physical state are reversible by changing the temperature. So like I said, you could just heat it back up and it would still be H2O, or you could freeze it again back into ice and it would still be H2O. Either way, it is that molecular makeup. But a chemical change cannot be reversed by a change in temperature. So this match that I lit earlier, I can't just turn it back into a match that I can light again, like with the green tip. I can't turn it back into one of these if I like put it in the microwave or the freezer. You know, it's gonna stay dead. I'm not gonna be able to use it again because a chemical change happened. It burned up all the whatever is on the tip, this green stuff. It burned it all up, so I cannot strike this match again. It does not work. If I heat it back up in the microwave or on the stove, it does not work again. But if I were to heat ice back up, it would still be H2O. but the chemical makeup on this switched, so I can no longer simply reverse it by a change in temperature. So, now we're gonna go over some questions. You don't have to answer them now, just think about them, because I will give you the answers, but it would be fun to try anyway. So, distinguishing between a physical change and a chemical change. This can be kind of confusing because a lot of things that you would think are physical changes or chemical changes are the other. So, try to keep that in mind. A. Frost forms as the temperature drops on a humid winter night. Would you think that is a physical or a chemical change? A cornstalk grows from a seed that is watered and fertilized. Chemical or physical? A match ignites to form ash and a mixture of the gases I was talking about earlier. See the smoke? Perspiration evaporates while you relax after jogging, a lot like the perspiration on this cup here. You can see my hands are wet now because the liquid inside is cold, but the outside is hot. So it is perspirating. Just like you perspirate and it evaporates when you relax after jogging. Another example, think again, physical or chemical. A silver fork tarnishes slowly in the air. Think of rust. What happens when things rust? So, does the substance just change its composition, or did it just change form? If there's a compositional change, it's a chemical change. So, let's see if your answers are correct. A. Frost forms as the temperature drops on a humid or winter night. Final answers. What do you think? It is a physical change. Exactly. If you got that, I don't know. The next question. A cornstalk grows from a seed that is watered and fertilized. Final answers? The answer is a chemical change. Congratulations if you got that right. A match ignites, remember, to form ash and a mixture of gases. An already ignited match. What did I say earlier? 2 matches after they're ignited, they cannot go back, so they are a chemical change. Exactly. You paid attention. You got that. D. Perspiration evaporates when you relax after jogging. Just like the cup of milk I showed you that was sweating because my room is hot. Well, that is a physical change. Yeah. Okay. Alright. Good job if you got that. I had some trouble on that the first time. A silver fork tarnishes slowly in the air. So like I said, what do you think happens whenever like a penny rusts? The copper starts to oxidize. So it is a chemical change. If you got those right, congratulations, because I think I may have gotten 1 or 2 wrong on my first try. Thank you so much for listening to my presentation, and hopefully you learned a bit. It definitely helped me learn a little bit more. Thank you. Oh, that is the next one. Don't look ahead.